Welcome to fourth grade English Language Arts. I am Mrs. Gooch of Mark Twain Elementary. Last time, we were reading Dinosaur Fleas. We were looking for key details while we read this book. Details that are very important that you must use to explain what the book is about. We were using these key details to answer the question, how do scientists know there were fleas during the time of the dinosaurs and that the fleas drank dinosaur blood to survive? How did they know that? We collected important vocabulary and important key details on a graphic organizer. Today, we will organize this information and look for evidence to support these key details. Let's read the learning target together. Ready? Begin. I will find evidence in an informational text that supports a key detail. Evidence is information that shows or proves something is true. What does it mean to support something? This stool, which is a tiny seat you might sit on, is supported by 3 legs. The legs hold it up and hold it in position. Information that supports a key detail helps that key detail make sense. Key details are important information that you must use to explain what a text is talking about. Let's read the success criteria together. Ready? Begin. I can use my text evidence to explain or describe a key detail. To explain something is to tell me more about it. To describe something means to tell me the characteristic. What is that thing like? We are trying to explain or describe key details using evidence that we find in the writing or in the text. When we explain or describe using evidence, we might use some sentences like this. For example, in other words, this is something you would say if you're going to explain it using different words. I know this because this shows that. Using these transition phrases can help people understand that you will be explaining or describing a key detail. We are getting ready to use a new tool to organize our key details and gather evidence. I would like you to make this tool with me. Go ahead and get some paper and something to write with. Draw a line across the top of your paper with some space above it. Draw another line going all the way down from that line you drew across. You will notice I have more space on the right side and just a little space on the left side. We call this a T-chart because it looks a little bit like a lopsided letter T. At the top of this tool, we are going to write our topic sentence or main idea. Since we are answering this question, we're going to write this question as a sentence. It says, how do scientists know this? What do scientists know? Scientists know that fleas drank the blood of dinosaurs. Let's use that for our topic sentence. Write it with me. Scientists know that fleas drank Let's say dinosaur blood. I know if somebody walked up and told me that, I'd say, really? How did they know that? Let's review the key details we gathered last time. Fleas survived by sucking the blood of dinosaurs. Scientists discovered fossils of fleas in China in 2012. The flea used its sharp, pointed feeding tube to pierce the dinosaur's hide and to draw out blood. Scientists studied fossils and figured out that fleas lived roughly 165 million years ago. When I organize my details, I like to put the same kinds of information together. That makes papers make more sense. I notice there's a detail here about the fleas drinking blood, and a detail here about how the fleas drank blood. And then I notice the other two details are talking about the scientists discovering fossils. So two details, one about scientists and fossils and one about how the fleas sucked the blood, might be the two main details, two key details that we are looking for. So the two kinds of information we found, the two key details we found, explaining how scientists know that fleas drank dinosaur blood, is that first, they discovered fossils. Let's write that here. They discovered fossils of fleas. What was the other clue that told them that the fleas drank dinosaur blood? Remember, when we looked at the fossils, they saw a sharp pointed feeding tube. So the fossil evidence was where they saw how the fleas drank the dinosaur blood. The fossils showed how fleas drank dinosaur blood to survive. That means to stay alive. We need to go back into the text to find good evidence to explain or describe how they discovered fossils of fleas. Here's a picture in the text of some fleas that lived during the age of the dinosaurs. The fossils show giant fleas. What else are the fossils showing? Let's check the text evidence. It says right here, the dinosaur fleas were not exactly the same as the fleas we know today. They were larger than today's fleas, just like many dinosaurs were larger than today's animals. So the fossils are showing that the fleas are larger in the time of the dinosaurs. It also says they also had saw-like mouths that were perfect for cutting into thick dinosaur hides. We talked about how that means skin. This diagram shows a cat flea that we have living today and a fossil of a dinosaur flea that lived during the time of the dinosaurs. It's also showing there's a size difference. This tiny dot represents the actual size of today's fleas. This inch-long blob, this big blob here, is the actual size the dinosaur fleas were, so they were much bigger. Remember how the text also said they were larger. I also notice it says there are piercing mouth parts. We talked about piercing means it punches a hole into something. Piercing mouth parts. The fossil also shows piercing mouth parts. So now we have two pieces of evidence to add to our tool. Okay, the first piece of evidence we found that the fleas were bigger was something the fossils showed. We can use that evidence to explain more about their discovering the fossils and how the fossils showed them that the fleas drank dinosaur blood. One thing that let them do that was they were bigger than today's fleas. Let's write that evidence in this big section here. The fossils showed that fleas were bigger during the time of the dinosaurs. The fossils showed that fleas were bigger during the time of the dinosaurs. Our other piece of evidence we found that they had piercing mouth parts. Should I put that with they discovered fossils, or the fossils showed how fleas drank dinosaur blood? What did they use the piercing mouth parts to do? Drank the dinosaur blood. So here we can write the fossils also showed that these fleas had piercing mouth parts. Let's see if we can find any more evidence to explain or describe how fossils showed fleas lived during the time of the dinosaurs and how the fossils showed how fleas drank dinosaur blood. Here's another important piece of evidence. By studying fossils, scientists have figured out that the dinosaur fleas lived roughly 165 million years ago. This means that the dinosaur fleas were alive at the same time as the spiky Stegosaurus and the long-necked Apatosaurus. So that means the fossils showed the scientists how long ago the fleas lived. The fossils showed that these fleas lived about 165 million years ago, comma, when there were dinosaurs. We also need more evidence to explain or describe how fleas drank dinosaur blood to survive. Let's look in the text. This diagram in the text explains the flea used its sharp, pointed feeding tube to pierce the dinosaur's hide, and to draw out blood. That is a really helpful piece of evidence. I would like to quote or cite this piece of evidence later when we do our writing. So I will also write down the page that information is on, which is page 8. Since I am going to write down the exact words the author used in the books, those are not my words. So I need to use quotation marks to show my readers that I am using someone else's words. The flea used its sharp, comma, pointed feeding tube to pierce the dinosaur's hide. Remember, this meaning of the word hide means the dinosaur's skin. They're not hiding from the fleas, but I bet they wanted to. Fleas are itchy. And to draw out blood. And I'll put more quotation notes. That means everything between these marks is someone else's words. So when I tell people this information, I need to let them know it is on page 8, tell them the title of the book where I found it and who wrote that book. That way, other people can look up the same information for themselves. Let's see if we're meeting our learning target and success criteria. Did we find evidence that supports our 2 key details? And does the evidence explain or describe more information about those key details? When we look at our graphic organizer, everything should support everything else. So everything in these bottom sections should be explaining or describing this topic up here at the top. Scientists know that fleas drank dinosaur blood. How do they know that? Because they discovered fossils of fleas. And what? What about that? Oh, the fossils show that fleas were bigger during the time of the dinosaurs, and the fossils show that these fleas lived 165 million years ago when there were dinosaurs. Oh, so that information is connected. These pieces of evidence explain or describe this key detail. Another reason they know fleas drank dinosaur blood is because the fossils showed how fleas drank dinosaur blood to survive. How did they do that? The fossils show that the fleas had piercing mouth parts. And there's a quote: the flea used its sharp pointed feeding tube to pierce the dinosaur's hide and to draw out blood. So our evidence is explaining and describing how the fleas were able to do that. And that is why we have met our success criteria and our learning target. Next time, we will take this information and write an informational paragraph to share this information with other people so they will be interested in reading about dinosaur fleas. Until then, keep reading and find books you love every day. Welcome to 4th grade mathematics. I am Mrs. Gooch of Mark Twain Elementary. Last time, we multiplied single-digit numbers by multiples of 10, multiples of 100, and multiples of 1,000. Today, we will use that skill to multiply single-digit numbers by other large multi-digit numbers using the standard algorithm. Let's read our learning target together. Ready? Begin. I will multiply a multi-digit number by a single-digit number. Multi means lots of. The digits are the number symbols inside of a number. So a multi-digit number, like 402, has more than one digit. A single-digit number just has one number, like 3. Let's read our success criteria together. Ready? Begin. I can use the standard algorithm of multiplication to multiply a multi-digit number by a single-digit number. When we say standard, we are talking about something you do the same way as everyone else. We agree on a certain way to do things. That's the standard. An algorithm is a series of steps that we follow to do something. So the steps that we follow to multiply a certain way, the same way every time, we call the standard algorithm of multiplication. Here is our example of a multi-digit number, 402, being multiplied by a single-digit number, 3. Go ahead and get a piece of paper and something to write with, and write this at the top. 6 times 26. This is a single-digit number times a two-digit number. We will use our old friend, the distributive property, to break up this 26 into smaller factors to create two partial products that are easier for us to figure out. Remember how we used to set that up? Two partial products that we will add together will give us the whole product. Each partial product is 6 times part of 26. What is this 2 worth? It's worth 20. So we put 20 into this side. And what about this 6? That's just 6 ones. Because of the distributive property, 6 times 26 is the same thing as 6 plus times 20 plus 6 times 6. Let's look at 6 times 20. Here, we can use the associative property. Remember this trick. This is a multiple of 10. There's a 0. We can cover up that 0 and think about what 6 times 2 is. It's 12. Since we associated the 6 times 2, that amount is now multiplied by 10. So we put a 0 in the ones place. 6 times 20 is 120. Now let's find the other partial product. 6 times 6. 6 times 6 is 36. If you have trouble remembering, you can think about 6 times 3, which is 18, plus 6 times 3, which is 18. 18 plus 18 would be 36. Now we have our two partial products, and the last thing we do is add them. We can use the standard algorithm for addition to do this. Start by lining up the numbers by place value and start with the ones column. 0 plus 6 is 6. 2 tens plus 3 tens is 5 tens. This is the tens column. And 100 plus nothing is 100. The entire product is 156. Have you noticed there's a lot of writing? You can go back and use this way to check your work or if the algorithm gets confusing. But let's see how much less writing there is when we use the standard algorithm. To do this, we are going to want to turn our paper sideways. So these lines are going up and down. I'll show you why. With the lines going up and down like this, we can set up our standard algorithm kind of like a place value chart. The problem we are working out is 6 times 26. Using these lines, we can write the number 26, putting one digit in each of the spaces the lines make. This is now the tens place, and this is the ones place. We will write the 6 underneath in the ones place, underneath the 6. Now we add a little symbol over here, a times symbol, a multiplication symbol, to show what math we are doing, and then we put a line. Lining up these digits by place value is a very important step. Now remember what we did with the distributive property. We began by multiplying 6 times 20, then we did 6 times 6, and we added them together. When we do the standard algorithm, we start with the ones column. So we will start with 6 times 6. Do you remember what it is? It's 36. 36 is 3 tens, see where I write it, and 6 ones. 36. We are regrouping these 3 tens over to here in the tens column, kind of how we do it when we use the addition algorithm. Now that we've done 6 times 6, it's time to do 6 times 2 tens. We know we're multiplying 6 times 20 here. We can say 6 times 2 tens will tell us how many tens. What is 6 times 2? All right, 6 times 2 is 12. 6 times 2 tens, or 6 times 20, was 120, remember. But 6 times 2 is 12, and we have 3 more tens here to group with those 12 tens. 12 tens plus 3 tens is 15 tens. And here's how I write that. 100 is in the 100 column, 5 tens is in the tens column, and these 6 ones are still in the ones column. So we get the same answer, 156, that we got with the distributive property. Now we have a single-digit number times a 3-digit number. Go ahead and write at the top of your paper 3 times 431. Let's use our old friend, the distributive property. First, we multiply 3 times. You know what? Since the algorithm has us starting with the ones place, let's do that while we're using the distributive property. 3 times 1 plus 3 times what is in the tens column. That's right, that's a 3, but how much is it worth? 30. So far we have 3 times 1 plus 3 times 30 plus 3 times, what's that going to be? 400. Now we have 1, 2, 3 partial products, not just 2. Let's figure out each expression. 3 times 1 is 3. 3 times 30, remember the associative property, cover the 0. 3 times 3 is 9. Put the 0 in the ones column because we are multiplying by 10 there. 30 is 3 times 10. What's 3 times 400? Cover up the zeros and remember 3 times 4 and then put the zeros in the ones and tens places. So our partial products are 3, 90, and 1200, or 1200. We can put a comma there. It's easier to add them up if I line them up nicely, oh. 3 plus 0 is 3 ones. 9 tens plus 0 tens is 9 tens. 200 and 1000. 1293. But again, it's good to practice the standard algorithm because not only does it take up less space on your paper and make you write less, it is often a lot faster. So let's try it out. Our problem is 3 times 431. So let's write 431 in our lines. Remember, my paper is sideways, so these lines are going up and down. 431. And we are multiplying it by 3. I write that 3 in the ones column. I put my math symbol and my line. 431 times 3. Which column do we start with? 3 times 1. We start with the ones. 3 times 1 is 3. 3 times 3 tens is how many tens? 3 times 3 is what we think of. It's 9. At 9 tens, what's the actual value of that 9? It's in the tens column, so it's really 90. 90 plus 3 is 93. We know that that's 9 tens because of where it is, because of its place. Now we've done 3 times 1 and 3 times 3 tens. Now it is time to do 3 times 4 hundreds. 3 times 4 is 12. Look where I've written it and think about why. Remember when we multiplied 3 times 400, we got 1200. That means this 2 is in the hundreds place and this 1 is in the thousands place. And that is exactly where I have written them. This 2 is in the hundreds column and this 1 is in the thousands. Our comma goes right here between the thousands and the hundreds. And we got the same answer. Notice how little we had to write. Practice will make the algorithm easier, but you always have the distributive property to fall back on. Remember, we are multiplying a multi-digit number by a single-digit number, and we can use the distributive property to do that. Our success criteria is for you to try to do the standard algorithm when multiplying large numbers together, because it will save you time and space on your paper. But if you get stuck with the steps, you can still use that distributive property. Here's a fun big number we're multiplying by a single digit. 5 times 2,653. I would have to make 4 different partial products. 5 times 3, 5 times 50, 5 times 600, 5 times 2,000. That's a lot to write, so I'll just use the standard algorithm. Let's turn our paper sideways. Let's write the bigger number first. 2,653. And it is being multiplied by 5, which I'm putting in the ones. Putting our math symbol and our line. All right. 5 times 3 is 15, which is 1 10 and 5 ones. I have regrouped the 10 the same way I would if I was adding. 5 times 5 tens, or 5 times 5, we say 25, and then we add this 10 that we regrouped. So 25 plus 1 will give us 26. 26 tens. I put the 2 here in the hundreds column and the 6 in the tens. 26 tens is really 2 hundreds and 6 tens, or 260. Now I am multiplying the 5 times the 6 hundreds. 5 times 6 is 30. That's 30 hundreds. And I'm going to add 2 more, which makes 32 hundreds. I put the 3 here and the 2 here. 32 hundreds is really the same thing as 3 thousands and 2 hundreds. So the 3 thousands have been regrouped up here into the thousands. Now I multiply 5 times 2,000, or 5 times 2 thousands, which is 10, and adding these 3 thousands, which makes 13. 13,265. Sometimes it takes practice to remember all of these steps, and especially how to use the regrouping. Remember, you still can use the distributive property to multiply single-digit numbers by multi-digit numbers. Practicing the algorithm will help you to do things faster. Are you able to use one of these strategies to multiply a big multi-digit number by a single digit? Were you able to line up your factors by place value and start working on the standard algorithm to multiply your numbers? We will use the distributive property strategy and the standard algorithm strategy next time to multiply together two-digit numbers. Until then, keep practicing and look for the math in everyday life.
Hola y bienvenidos a Matemáticas de cuarto grado en español. Yo soy su maestra, señora Saldana. Empezaremos la lección de hoy. Antes de empezar, vamos a necesitar algunos materiales para esta lección de hoy. Los materiales que vamos a necesitar hoy son un lápiz o lapicero, un papel con líneas o sin líneas, y si tienes las notas de la lección anterior y si tienes espacio, puedes seguir usando ese papel también. Cuando están listos, pueden decir listos en voz alta o pueden mostrar que están listos con un dedo arriba, así. ¿Están listos? Perfecto, seguimos. Primero vamos a listar nuestro papel. Vamos a tomar notas sobre la lección de hoy. ¿Sabías que tomar notas te ayuda a recordar mejor la información que aprendes? Sigue estos pasos conmigo para listar tu papel para tomar notas sobre la lección de hoy. Paso número 1. Dibuja una línea vertical en el medio de tu papel. Eso quiere decir de un lado hacia el otro. Paso número 2. Dibuja una línea horizontal en tu papel. Eso quiere decir desde arriba hasta abajo. Paso número 3. Numera cada caja 1 a 4. No importa el orden. Paso número 4. Escribe tu nombre y la fecha de hoy en caja número 1. Les doy un momento para terminar estos pasos. Cuando están listos, pueden decir listos en voz alta o mostrar que están listos con un dedo arriba. ¿Escuchó listos? Perfecto, seguimos. Toma un momento para chequear que tu papel se mira como el mío. ¿Tu papel tiene tu nombre y la fecha de hoy? ¿Tiene 4 cajas? ¿Y tiene los números 1 a 4? ¿Sí? Perfecto. Seguimos. Vamos a repasar el tema y la meta de aprendizaje de la lección de hoy. Primero, el tema que vamos a cubrir hoy es multiplicación, específicamente multiplicando números de un dígito y 2 dígitos con números de 1 y 2 dígitos en problemas de palabras para encontrar el área y perímetro. El vocabulario académico, eso quiere decir palabras que no usas cada día. Nuestro vocabulario académico de esta lección de hoy es la palabra multiplicación, área y perímetro. Multiplicación quiere decir sumar un número tantas veces como indica otro número. Área quiere decir todo el espacio que queda encerrado entre los límites de una figura. Y perímetro quiere decir la suma de todas las longitudes de un conjunto de líneas. Vamos a hablar más sobre el área y el perímetro hoy en esta lección. Seguimos. La meta de aprendizaje de hoy, acuérdense, eso es lo que quieres lograr aprender después de la lección. La meta de aprendizaje de hoy es, léelo conmigo. Practicaré la multiplicación de números de 1 y 2 dígitos usando lo que sé sobre el valor posicional y modelos útiles para encontrar el área y perímetro de diferentes problemas. Aquí abajo tenemos 2 figuras. La primera figura muestra área. Acuérdense, área es todo lo que es adentro de una figura. Y perímetro quiere decir la longitud de los lados de una figura, como este rectángulo de aquí. ¿Estamos listos para empezar? Pueden decir listos o mostrar que están listos con un dedo arriba. ¿Veo dedos arriba? ¿Escucho listos? Perfecto, seguimos. En caja número 1 de tus notas, pueden tomar notas sobre la página que está aquí enfrente de ustedes. Vamos a repasar cómo encontrar el perímetro de una figura. Acuérdense que el perímetro es la suma de todas las longitudes de un conjunto de líneas. Eso quiere decir alrededor de toda una figura. Por ejemplo, un lado o longitud de este cuadro mide 15 pies. ¿Qué es el perímetro del cuadro en total? Primero voy a escoger qué modelo útil voy a usar para ayudarme a encontrar la respuesta a este problema. Para este problema voy a usar productos parciales. Voy a usar lo que sé sobre cuadros para ayudarme a hallar la respuesta también. ¿Qué saben ustedes sobre cuadros para ayudarnos a encontrar la respuesta sobre este problema? Toma un momento para pensar. ¿Qué sé sobre cuadros? Pues yo sé que un cuadro tiene 4 lados que tienen que ser el mismo longitud de cada lado. Entonces, con esa información puedo empezar. Yo sé que sería 15 multiplicado por 4 lados que tienen el mismo longitud. Entonces escribo mi problema. 15 multiplicado por 4. Y ahora puedo empezar a multiplicar. Empiezo con mis unidades. 4 multiplicado por 5. Eso me da 20. Luego multiplico mis decenas. 4 multiplicado por 10 decenas. Eso me da 40. Ahora les tengo que sumar. Sumo 20 más 40. Eso me da la respuesta de 60. Entonces, la respuesta a este problema, que es el perímetro del cuadro en total, es 60 pies en perímetro. Todo el alrededor del cuadro. Toma un momento para tomar notas sobre la página enfrente de ustedes. Pueden decir listos cuando están listos o mostrar que están listos con su dedo arriba. ¿Están listos? Perfecto, seguimos. En tu papel pueden tomar notas sobre esta página en cuadro número 2. Ahora vamos a repasar cómo encontrar el área de una figura. Para encontrar el área de una figura, tienes que multiplicar su longitud por su anchura. Por ejemplo, mira este rectángulo. Este rectángulo mide 8 pies por 22 pies. Para encontrar la respuesta a este problema, voy a usar uno de mis modelos útiles. Para encontrar la respuesta para este problema, voy a usar el modelo de área. Primero, voy a escribir en forma expandida el número más grande. Entonces escribo 22 mostrando mis 20 decenas y mis 2 unidades. Ahora puedo empezar a multiplicar adentro del rectángulo. 8 multiplicado por 20 me da 160. Luego tengo 8 multiplicado por 2, que me da 16. Ahora puedo sumar las respuestas o los productos de estos dos problemas de multiplicación para encontrar el área. Sumo 160 más 16 me da 176 pies cuadrados. Eso sería el área de este rectángulo. Es fácil, ¿no? Toma un momento para escribir notas sobre la página. Pueden decir listos cuando están listos o mostrar que están listos con 2 dedos arriba. ¿Veo dedos arriba? ¿Escucho listos? Perfecto, seguimos. Otro problema de práctica. Pueden escribir notas sobre este problema en caja número 3 de tus notas. Léelo conmigo. Andrea quiere saber el perímetro y el área de su mesa de cenar. Sabe que es un rectángulo y que un lado mide 14 pies y el otro 8 pies. ¿Qué sería el perímetro y el área de la mesa de cenar de Andrea? Primero, tenemos que escoger el modelo útil que vamos a usar para ayudarnos a responder esta pregunta. Para este problema, vamos a usar el modelo de área. Empezamos con escribir 14 en la forma expandida, mostrando 10 decenas y 4 unidades. Luego, multiplicamos 10 por 8. Y eso me da 80. Y movemos a nuestras unidades. Multiplicamos 8 por 4. que me da 32. ¿Puedes decir en voz alta qué sería el próximo paso? Buen trabajo. Sí, es sumar los productos de los problemas de multiplicación. Eso me da el área de 80 más 32. Me da 112 pies cuadrados para el área. ¿Cómo encuentro el perímetro de este problema? Para encontrar el perímetro, tengo que sumar todos los lados. Eso sería 14 más 14, los lados más largos, y 8 más 8. Eso me da el perímetro de 44 pies. Toma un momento para tomar notas sobre esta página enfrente de ustedes. Pueden decir listos cuando están listos o mostrar que están listos con un dedo arriba o dos dedos arriba. ¿Están listos? Perfecto, seguimos. Toma un momento para escribir estos problemas de práctica para más tarde. Puedes escribirlos en caja número 4 de tus notas. Escribe problema número 1. ¿Qué sería el perímetro y el área de un rectángulo de 22 pies por 45 pies? Problema número 2. ¿Qué sería el perímetro y el área de un rectángulo de 36 pies por 12 pies? Problema número 3. ¿Qué sería el perímetro y el área de un cuadrado de 89 pies por 4 pies? Intenta usar uno de los modelos útiles para ayudarte a hallar las respuestas a estos problemas. Toma un momento para terminar de copiar los problemas en tu papel en cuadro número 4. Pueden decir listos cuando están listos para seguir o mostrar que están listos con un dedo arriba. ¿Están listos? Perfecto, seguimos. Ahora paramos. Toma un momento para reflexionar sobre el aprendizaje de hoy. ¿Sientes que lograste cumplir la meta de aprendizaje de hoy? ¿Te acuerdas de la meta? Léelo conmigo. Practicaré la multiplicación de números de 1 y 2 dígitos usando lo que sé sobre el valor posicional y modelos útiles para encontrar el área y perímetro de diferentes problemas. Practicaste eso mucho hoy, ¿no? Y tienes problemas para practicar más tarde. Eso es todo para la lección de hoy. Adiós y hasta la próxima vez. Bye.